Hello, everyone. Thank you so much for coming to my talk. So before I get started talking on some really exciting experimental features my team at Square is working on, I'd like to say thank you so much for RubyKaigi. So RubyKaigi is actually the first conference that ever accepted my CFP. So this is really quite an honor to be here with you all today. And thank you all so much for coming. A little bit about me. So this is me with my dog, and they say pets take after their owners. I think this is evidence of that. And so I'm born in Beijing, but I'm from a place called St. Louis, Missouri in America, and that's where it is, in case you guys are wondering. But now I live in San Francisco. So since I've been in San Francisco, I traveled around a lot. I've been to Japan, loved it here. I love the animals here. But something else I noticed is that Japan loves cash. And this is where I mentioned that I work at a company called Square, and we are a payments company, right? So we started off as this little thing you can plug into your phone. So it makes taking card payments, which is the norm in America, taking credit, debit card payments very easy for any merchant. And then, now we've evolved into a bigger company, and we offer omni-channel solutions. So we have APIs that offer offline payments, and then also in-app payment SDKs, and also obviously APIs, so you can take payments on your e-commerce website as well. And we also have our hardware, which is probably what we're known for the most. And this is another set of hardware. But what you don't know probably here in Japan is we offer a whole ecosystem of products. So we do payroll, we do basically everything you need to run a business. And in addition to promoting my company, this has a bigger point to it, and it's that for anyone, not just Square, as your business grows and matures, your scope widens as you enter more markets. And for us as engineers, that makes the business objects you have to model and the business objects relationship with other business objects increasingly more complex. And we need to build applications that can be up to speed with the business logic. And oh yeah, we also do the card. And at Square, we have an internal dashboard that you can think we keep track of all of our entities. And we use this dashboard to make sure that our merchants are legitimate and that their business is healthy. And this is what my team works on. You can imagine what we do is we get data from all of our product teams. So, they're very specific. We acquire all that data and we demonstrate it on a dashboard so that our agents can look at it and make sure that, oh, this, merchant really exists, or this payment, it got refunded, that's all successful. So it manages the day-to-day operations. And this has grown to be a monolithic application with 273,000 lines of Ruby, 22,000 lines of YAML, over 200 controllers, talking to over 150 services internally alone. And that is where we look for a solution in GraphQL. For those who are not as familiar with GraphQL, similar to how REST is a set of ideas for querying, for asking for resources from your server, GraphQL is a set of ideas where your server has to structure your app data like a schema, and then your client has the power to query anything it wants as long as it's within the realm of the schema, kind of like a database query, except your resource is no longer your DB, your resource is your app data in your server. So let's just look at what's the problem with REST, right? The first problem, if you just look at this, you can't tell me what this responds with. You can guess, but you really can't tell me what this is going to give me back, right? And so say it gives me something back very reasonable. But if we want to do like a general display like this, we have already underfetched since REST is one resource only. So to demonstrate how GraphQL is a little bit different, I'm going to do real quick. And that's the end of my talk. Thanks for coming. All right, we're back. So here you see this is what a GraphQL query would look like. So we have something like a payment, and I can go ahead and add a field like amount, and I can run it, and there it is. I can go ahead and take it away, and then we're doing it. So this gets rid of implementing several different REST APIs both on your front end and in your back end. And what you fundamentally have is one very smart endpoint instead of several controllers. So now let's go back to my slides. So GraphQL, well, I'm not here to convince you that GraphQL is a better choice over REST. I think certain use cases, REST is totally fine. But for us, we are querying for data from multiple different resources. Our data is highly diverse, and our data is most valuable to us when it's relational. If you think about it, the fact that a payment's $1,000, what's going on? Oh. The fact that a payment, maybe I can just use this one instead. And so I'm not having the problem that I'm having right now with this mic. Here we go. Let me turn this off. This is the last technical problem. Promise. All right. So what we see here, everyone can hear me just fine, right? Perfect. So if you think about our data is not that effective if we just know that a payment's $1,000 and this merchant is a coffee shop owner. What is meaningful to us is why did a coffee shop owner just take a payment of $1,000? That is risky behavior and needs to have a closer look at it. So today's roadmap, right? I want to talk to you about what we have already, our existing architecture. Then I am going to step by step walk you through how to write a GraphQL API. And then secondly, we are going to talk about how we can metaprogram certain parts of it away. And then I want to see that even metaprogrammed away, this API is still flexible and won't give us weird bugs. And finally, I'm going to touch on testing. So here's our existing architecture, right? So we get our data from a bunch of different services. You may get your data from, your app's database. And then we have our Rails backend, which then communicates through another REST layer to our front end. And we use Ember at Square. And then ultimately our agents communicates with the front end. And I'm going to scope today's talk to just replacing that one REST layer between our backend and front end. And we need to talk about something called targets before I can get any deeper into GraphQL. And this is really important for when we do the metaprogramming. So data comes in right from these services, check it out, in any shape or form. And we move it to our target layer. And all target is a class that wraps raw data so that it can interact with each other and our backend with the same unified API. So in tech terms, they now all speak targets, all right? So let's just look at the source code for this real quick. And all the code I'm showing you is from a personal prototype. So I removed an insane amount of abstractions and defensive programming that would be required in a production, environment. So all of our targets inherit a target base class. And also all it does is tell me how to fetch the data, fetches the data with a method that you defined, and all targets have IDs. So I just stuck it right there. And this is today's data model. And this is what I'm going to be persisting throughout my entire talk. We have a payment, and is associated to a merchant through a merchant ID. So what does an actual target look like? I put the stub in the top just so it's very clear what data we're expecting. And then so I tell it how to fetch the data. And it's just some nonsense merchant client that just calls my stub. And then it has a field I gave it called store name. All right, and here is a payment, exact same thing. And the only thing that's a little bit more complicated about it is that since the payment is associated with the merchant, I have a field called merchant on it, where we either memoize it or since a merchant's already a target, we can call it with this really nice merchant.lookup API. And that's all you need to know about targets. So I did some console simulation to show you how it would look like. And if we want the merchant of the payment, here's the merchant. We can grab a field off the merchant, and merchant works as we would expect. All right, so let's write a GraphQL API for our data model. So your data needs to be structured like a graph, and this is what it would look like from a bird's eye view. It enters through a GraphQL controller, and something I want to emphasize real quick is that your GraphQL controller can exist in harmony with your REST controllers. If, say, something like hardware and bank accounts is not on GraphQL anymore, it doesn't have to be, right? So let's go back to the GraphQL, which is, it asks first, is it a query mutation? Basically, is it a read or a write? And we'll just be focusing on reads today. And then ask, okay, is it payment or merchant? Which one are you querying? And then it resolves each field until it gets to one of the leaf nodes. And with payment, obviously, it's a little bit more complex as a merchant for one of its fields. So this was the query that I was showing you in the graphical interface. And let's put it to the side for reference. So we enter a GraphQL controller. And the first thing we do is we call execute on the demo schema. And it's pretty straightforward. It passes in the query and the variables. And then we go into the demo schema. Which one is it? It's a query type. Great. And then it goes into query type. It sees that it is a payment. So the first thing that GraphQL does is it parses. So if you are querying nonsense, it'll just break immediately. But the second thing it does is does validation. And to understand validation, let's look more closely at these three fields. It sees that I want a payment, and it needs to have an ID, which is of type ID, which is just a string GraphQL, or an integer, but it'll convert it to a string. And it is required. Did our query, follow the definition? Yes, it did. So that's good. Then it'll look closer at what the payment type is. So it evaluates this block, and it basically just goes ahead and checks all the fields are correct. And ID amount, there's nothing more to resolve. We're done. But we do need to look a little bit closer at merchant. So what is merchant? It goes to a class called merchant type, and then it validates per field. And then with that, we're like, this is good. And then to actually return the data, it looks for a resolver. And a resolver is just a function that matches the name of your field. And the great thing about resolvers is that resolvers are pure functions, meaning at line 12, you can put whatever you want in there. I put my target logic, but that could be a Mongo query, that could be a SQL query, it could be a client call. So it is resource agnostic. And with that, it just calls the payment lookup method, and it returns our data. So after that walkthrough, which parts of it can we metaprogram away? And is metaprogramming even a good idea? So these are the 3 ideas I want you to keep in your mind as I go through this main technical section, which is, with metaprogramming, is it still flexible? Are we going to get weird bugs from this, or is this really a good and elegant pattern to follow? 2, obviously, does it reduce boilerplate, which is just repetitive code? And 3, does it give us a better developer experience? So just another bird's eye view, because I really want to hammer this point home. GraphQL controller goes to demo schema. It goes into our query type, and it validates using these GraphQL type classes. And then if it validates, then it'll go to the root type resolvers. And then it calls, in my case, my app data to actually fetch the response. So if I look at this, I see I already have my target classes. That's done. And you saw in my demo, there were like 10 lines of code that was relevant in this section. What gets really repetitive and laborsome are going to be these GraphQL type classes and your definitions and query type. And I put these boxes to represent, in a real production application, there's going to be hundreds and hundreds of business objects. And you imagine that writing these out manually will be incredibly laborsome. So let's take a look at GraphQL type classes real quick. And you might notice just from the name GraphQL type classes, we have a problem. Ruby is not typed. So what can we do? I'm going to talk about target class annotations real quick, which is how we're going to mark up our existing model so that we do know the types of each field. So wouldn't it be nice if I had my payment and merchant and I had some metadata, say like a class variable in my case, that can tell me what the fields are. And this is the result I want. So I can call payment.graphql field annotations, and it'll give me a nice, say hashback of each field. And in GraphQL, you need at least a type and whether or not it could be null to be able to define a field. And we'll just be sticking with those bare bones requirements today. So here is our target. Here's what it looks like after we add our annotations. So to add our annotations, here are some 2 concepts I want to talk about: dynamic methods and unbound methods. Dynamic methods are really straightforward, right? They're just methods whose names and definitions are defined during runtime. Unbound methods, and I'm going to do a pretty trivial example just to show off the concept, is I have something like def sound, and it takes a sound, and it just puts sound is this. Oop. Okay, cool. And what an unbound method is, when you think of a method, it's normally associated with a class or an object, right? But unbound method is not really associated with anything, and it needs to be bound to something later on. And you can get the unbound method, which I'm going to name which is calling instance method. And since this one is defined on the module. Sorry? Oh, sorry. Thank you. I would have never seen that standing up here. And then, so now we have the unbound method. And what I can do is, let me just define a new class. Just do class.new on it. And then what I can do is I can do um.bind to the dog. I can call it with whatever, right? And now it makes a sound. So that's the concept I'm going to be using for my target class annotation. So that's my concept demo. Let's hold on to some of the code for reference, and we can walk through this class. So first thing we understand, what is self? Self, even though we're in this target annotation class, self is the payment class, because that's where we are calling it in. And then what is definition that we passed in? Definition, as you see we passed in, is actually just the method, say amount. And then luckily for us, a definition returns a symbol of the name, which is really convenient for building our hash. And then we can go ahead, take the type and whether or not it can be null, grab the unbound method off of it, and then, which is just amount. And then we can use the dynamic method, so we're actually defining amount, and then place it back onto self, which again is just payment, and then call it. So what we've done is, even though we passed this amount in as a parameter for our annotate field call, we have now placed the method back onto the class, so our targets, even with the annotations, still preserves its original functionality. So with that done, let's generate the GraphQL type classes. This is what I want. I want, say like, I have something like a GraphQL type generator. I can pass in an array of all of my target classes, and then it gives me back a mapping. And this next line will make it a little bit clearer. It gives me back a mapping of target classes to the GraphQL type class. So that way, when I need to acquire it, it's pretty easy. And also, when this is initialized, it creates those classes as well. If I need the merchant, it returns me types, merchant types. And just so we're clear, all GraphQL types is in the namespace of types, and that's where that's coming from. So here are the concepts, right, which are the Ruby object model and constants. You saw me doing this previously, but say dog, right? A class, let's make another class. Let's say goat. So goat, if you look at the class of a class definition, is nothing but a class itself. So a class definition is nothing but an instance of the class. And a class is nothing more than just an object. So if we look at the superclass of goat, it indeed is an object. And this is something that allows us to not really exploit the language, but it allows us to do metaprogramming. So if we go back into here, I forgot to say, and class names, right, are just nothing but constants that are then set to that definition. So I defined this, let's just do kernel, that const set, and I can set maybe the name dog to my dog class. Oh, whoops. It was already set, but I can go ahead. Let me just set goat. I may have already set goat as well when I was testing it. No, it's there. And great. That's all it is that it's a class name, it's just a constant. So we can dynamically create classes very easily with these two concepts. So here is my GraphQL type generator. I go ahead and initialize the instance variable. We pass in our target classes. And then the interesting thing happens within this each loop, which is we first define our constants, right, as our GraphQL type class name. And then we go ahead and set a constant in the type namespace with our GraphQL type class and class.new. And the parameter that you pass in is the superclass of it. And like I said before, all GraphQL types inherit from the type's base object. And I went ahead and I did some syntactic highlighting. So it's very clear like where the metaprogramming matches the actual written out code. So we've created the shell, right? The shell of our classes. Now we need to go back and define the fields. And this is a lot more straightforward and actually doesn't really require any metaprogramming. So we have to understand what that field called actually does. And when you do something like field, amount, integer, not null, what is it actually doing? What it does is it goes to the GraphQL type class and it appends a new entry into the OwnFields hash. So if you look at OwnFields, it gives you, and you like open one of the objects up, you see that it is a GraphQL schema field object. If you actually look at a value, yeah, indeed, it is this object. So what we have to do is we go ahead and we go back and we iterate through the target classes. And then we just pull out from our annotations the field type, whether or not it can be null. And we go ahead and just call that method on our GraphQL type class. And again, I did some syntactic highlighting, so it's clear where everything is coming from. And then all you gotta do is you just gotta call it. In my prototype, I call it in query class and the query type because I was just like the last place it could be before stop working. But you could maybe call it an initializer, whatever works for you. So with that done, we're halfway through. we can focus on how do we define our root types on our query. So if you see me using this term, root type is just like a point where you can start entering your schema. That's what a root type is. So this is the written out code. And you see very clearly that it's split out into two parts, which is the field definitions and the resolvers. So let's first look at how we define lines 3 through 9. And let's hold it down for reference. And to define these fields, all we got to do is go through our GraphQL type generator and just say every single target is a valid root type for us. We can enter through any point of our schema. All we got to do is we're just interpolating the field name, right? So I grab the field name and I more or less plug the original code into my, my call. So with that done, let's look at how we would do our resolvers. Oh, and gets rid of boilerplate. Sorry. But let's look at how we get rid of our resolvers. And this is also very straightforward. We just go ahead and we define a method dynamically with our field name. And then, weird animation there. And then we interpolate the target classes. And then we call target class.lookup. And of course, if you have a more complex lookup, you would pass in maybe a block here instead of just hard coding, target class.lookup ID. So now we can go ahead and do the demo. If you can believe me, sorry, it got a little bit shuffled. If you can believe me, at this point, I've removed all target types within my code base. There's not a single GraphQL type in my code except for the base query type. So now I can go through and we can call merchant ID. And you see, because it preloads your schema, it can actually do a lot of syntactic checking. For example, if I type some nonsense, I can highlight it and be like, why is it wrong? Oh, it doesn't exist. And it will tell you what does exist. And then you can go ahead and say, I want the merchant at this level with the ID and the store name. Don't do that. And it's, sorry, didn't mean to do that. It's not there. But you see how this is incredibly powerful for your client. Like, how many endpoints do you get rid of by having this? So the next thing I want to do is let's add a new business object, right? So this was our original data model. Let me go ahead and add a card. Say a card is associated to a payment. Very straightforward. And all I've done is I went in and added a new target called card. Here's the stub, and it's associated to a payment. Great. So what I'm going to do, I'm going to cheat a little bit because in my code, I can now find it. Yep. I'm just going to go ahead and add card back into my array. Save that. If I go ahead and refresh, we can see if I go like, what are the things that I can query, type some nonsense, I see, okay, card is one of them now. And then I can do, I forgot to put in the ID. The ID of stub is 7890. ID. And then I can do, okay, I want the ID, I want to save the postal code. And this similar to, I guess, like Swagger UI has something like this as well, where you have the documentation and you can test your queries. But okay, adding a card is very simple. And just to prove, we also have payments because it was associated to a payment, right? And then amount. Great. And I haven't added any endpoints, and I'm querying all these different types of data. So what about some bigger fundamental changes where the structure of our data changes completely? Let's say, I don't care who the client is. You don't get to just ask for someone's credit card information. Like, this is not acceptable. You can only look at someone's credit card if you have the rights to look at a payment that maybe was fraudulent. So you see how I've changed the structure. You can only access the credit card information through the path of the payment. You can no longer directly be like, give me someone's credit card number. So what can we do then? So what we can do is we can limit the root types in our GraphQL schema. So instead of putting payments here, we can restrict it. Instead of putting cards here, we can just restrict it to only be allowed to view a payment in a merchant. And then instead of iterating through all the different target types, we can make an array of, say, just valid target types. And in here, we only have payment and merchant. And then with that, let me go ahead back into my code and remove card. Let's also remove merchant. Let's just say you can't view a card or a merchant unless you have a right to their payment. So if I go ahead and refresh, you're going to see very quickly it immediately highlights card as inaccurate. And if I tried to run it anyways, it'd be like, card doesn't exist. But if I go ahead and we put this back nested inside of my payment call, and I won't be needing ID anymore. And I run it, there it is. So through the path of my payment, I can still access my card, despite the fact that I can't directly access my card at the root level. And really quick disclaimer, this by no means takes away in-app validations. Like, you need to implement your permissions, you need to implement authentication. But what this does give you is an incredibly smart and powerful API that understands your business logic without you having to implement that yourself in the front end and the back end. And the shape of your data is the relationship between your business objects. And with that done, I want to touch on tests. Similarly to what Matt said during his keynote, I also hate tests because it's difficult. They're very difficult to write sometimes if your code's not fit for it. But with metaprogramming, and I don't expect you to read this, but what metaprogramming achieves is that instead of testing hundreds of business objects separately and writing these tests that are both meticulous and error-prone, you can just write tests for one code path, right? If all your models are generated through metaprogramming, as long as your metaprogramming works, you can be pretty sure that your GraphQL types are also good. So, I just did some quick and dirty, like nothing really that solid test to be like, initially, types doesn't exist, but then I generate all my types, and then boom, I go through all my targets, and now they do exist, and the names match. And similar thing with just testing the fields, right? I just go through and I add all my fields with the data that I mocked, and I make sure that, okay, the type that it returns is correct, and whether or not it's null is also correct. And so that, if we revisit our checklist, I would say, yeah, I do really believe, even just at this level of prototyping, that using metaprogramming can keep our API flexible still. I think metaprogramming gets a bad rap, right? Because sometimes people use it, and it's just like someone else looks at it and be like, I have no clue what's going on. But I do believe when it's used in an isolated case where it's used specifically for something rather than just, Ruby black magic, is actually a very elegant solution. 2, I think without doubt, it reduces repetitive code. And 3, it does, in my opinion, improve developer experience just on the fact alone that I don't have to write an individual test for every single GraphQL type, and I can write one test that can covers the generation of all of them is pretty amazing. So with that is the end of my talk. I want to thank you so much. And also, I would like to thank my team at Square. Without their mentoring and everything, this talk could not have happened. And with that, I wanted to say if anyone is interested with developing with Square, please talk to this guy at this email right here. He actually speaks Japanese as well, which is a huge improvement from me. And with that, it is the end. Thank you so much. Do you have questions or? Questions, all right. I'm open now to take some questions. Yes, sir.
Thank you very much for your talk. Yes. We are using GraphQL for mostly 1 year. We are pretty happy with it, and encourage everyone to use GraphQL too, because it has some capabilities. And amongst others, it have a good documentation tools like GraphQL that you showed to us. With your metaprogramming approach, how do you handle documentation of the schema of such auto-generated models?
Right. So what he asked is GraphQL allows you to document each field and each type of your schema and how that would be handled in metaprogramming. With that, I can actually refer back to one of my slides where we generate the fields. You see with my fields, the only thing I did as I skimmed through my 200 slides, the only fields that I did, if you want to look right here, is just ID is just the type that it returns and whether or not it could be null. What we would add here would be another field, which is the docs, right? And in a realistic environment, you wouldn't list this out inline it. It would be, I would assume, an array or a hash where, GraphQL has dozens of different fields that you can, customize and like look aheads. And that's where we would put it. Does that make sense? You're talking about the innate documentation that you can put in your code, right?
Yes, in my experience, even in internal API, so when we just have backend and front end, and we don't let access other people to other applications to our API, it's very useful to have documentation. It allows front end to understand what is the data going in the API. And so you said that we can put documentation strings somewhere to the hash or array. And can you say how to plug this hash to the auto-generator schema?
Yeah. So what I was saying earlier is instead of having written out field type equals field definition of type and nullable equals this, it would be another maybe loop inside that iterates through all of the possible fields that you can do, like docs, required or not, everything. So it wouldn't be inline. It would iterate through all the different ways that you can customize your fields, and it would do that instead.
Okay, thank you very much.
Thank you. We can talk later if that wasn't clear enough. Thanks. Anyone else? You can ask me about my dog too. I take those questions. Doesn't have to be about GraphQL.
Okay, I have a question about the performance. So if you define types, and I think you may need to care about the performance on the backend side and the services through the REST API. How do you handle the cases? For example, you need to fetch the data as a bulk from the backend services to the front end, to the GraphQL client.
Right. So very good question. So when we first started implementing GraphQL, even without the metaprogramming, one thing we did notice really badly was performance had to be really good in your backend. Because if I look at this slide right here very quickly, you see how since your data is structured like a graph, the moment that, so I'm not going to find it, but if you have like a top level query that's really slow, all the node leaves are just not, it's going to time out, right? Very careful monitoring, and also very heavy caching, to the point where it's probably, we should cache a little bit less. But it's also really, so a great thing about GraphQL is that you can evaluate how long a query may take before you even get it back. For example, it allows for a lot of introspection, which is, for example, I can be like, my queries can be no longer than 7 levels deep. If it's deeper than 7 levels, I will, return error. And you can also do tracing, whereas like I know to get a bank account, maybe it takes about, on average 5 seconds, or that's just very long. But if I can add up the times for each of these queries, then I know, okay, I can estimate this will take about 2 minutes. And you can do that. And something else that people tend to do is instead of having your front end send over, that big chunk, because, GraphQL, there's a lot of text if your queries get very big. You can send over an ID that matches a query that is stored in your server, right? And if your query is stored in your server, then you know a lot of information about it.
Okay. Thank you.
Thank you. Yes.
Thanks for the talk. My question is, with JSON, we can send JSON from the front end, and the back end can return, for example, if there are errors, we can specify the message and all those kind of stuff with custom formatting, and the front end can just display it appropriately. How to do that in GraphQL?
Yeah, so great question. So he asked, how does GraphQL display errors? The great thing about GraphQL is you know exactly what it's going to respond. It's going to respond with data that is exactly the shape of your query, or it's going to respond with an error. So if I do something that doesn't really make sense, like I do that, and I query it, if anything errors out, and obviously you can customize it, every GraphQL query has an error field that is an array, and it has message, locations, path, and extensions. This is, if you use the GraphQL Ruby gem, this is given to you for free. And since you know that your data is always going to look like one way or another, we can just parse through this and display whatever error your client should see. Any other questions? Going once, twice. You can ask about my dog too. Good. All right, I think that's it. Thank you guys so much. If you want to talk more.